Hello, I'm Tom Hollingsworth, and welcome to Networking Field Day. We are here in Palo Alto, California, with our friends from Apstra. We are going to be listening in about their new product and solution, and we have around the table a group of Networking Field Day delegates. They represent the best and brightest podcasters, speakers, writers, and influencers in the community. They are going to be asking questions, making comments, and offering their opinions as part of an invited panel. If you would like to learn more about this event, including how to become one of these delegates or a presenter, please go to our website at techfieldday.com. You can also find more videos like this about a variety of technical subjects at our YouTube channel, which is at youtube.com/techfieldday.
As a network architect or designer, you know the kind of network you want to build, and you've created mappings from these generic nodes to several different vendors, and this is sitting in a repository somewhere. And then at some later date, somebody has to build an L3 clause in some data center, and you want this design to be sort of a standard, but again, you may not necessarily want to choose the exact switch model at the time you make the design. So what you're going to see here is what will happen at the time you actually want to build the network.
That's right. Now we know that when we build out a network implementation or a pod, that pod is going to need information that the implementation engineer provides, like IP addresses and ASN values and all the magic numbers that are needed in order to make this pod unique. And managing magic numbers sucks. Nobody likes to do it. But you can. But what we have is in the product is a concept of resources that we allow you to define pools, and then AOS will take those pools and then allocate those values across the network service for you. You can overwrite everything. You don't have to use the pools. But what I'm going to do is I'm going to set up some pools that I'm going to use. And because you don't want to watch me type this in anymore because you're looking like you don't want me to do that, I'm going to do this through an automated process. We have some Ansible modules that we've developed that automate our AOS API, so that you as a network engineer that like to use Ansible for stuff, you can automate our product through Ansible. So I'm going to say make blueprint dependencies, and really what this is doing is loading some JSON files that are on my laptop using Ansible, which I love to do. And you can see that I have defined an ASN pool called private ASNs, and I've created an IP address pool, one that I'm going to use to allocate on all my switches, and maybe another IP address pool that I'm going to use to allocate on my servers. And then finally, I have edge routers. So when we say this pod is connected to an edge router, there is some information that we need to know about that edge router when we implement the config. We at least need to know the loopback address and the ASN number for creating all the BGP peering. So now that I have these resources and I have all my templates and widgets, I'm going to build a blueprint. So I'm going to say I want to create a blueprint based on this design called Design Together, and I'm going to call our blueprint Rack Together. And I can see, the intent of this design is to provide service to 75 servers. I can see that it's going to result in 2 spines and 2 leafs. I can see information about those abstractions. So what AOS is doing is saying, based on that information, I'm going to create essentially all of the inputs now, everything that you need to provide in what we would call this build area. So this is what the implementation engineer would need to fill out. And I'll go through these. The first one we might want to do is pick the vendors that we want to use as our spines and leaves. And you can see AOS will show you all the possible ones, but it will only let you choose the ones for which you've created the logical maps. So for example, this Dell that it's showing us, if I were to look at the map, it was the Dell map that we just created. So I'm going to select the layer 3 server. This is our 10 gig server, which is in the rack. This is my spine, and this is my leaf. And now I'm going to fill in kind of these service parameters. So for example, for ASNs, because we're doing BGP, I'm going to say I want this pool to be used on all of these types of devices, my spines, my leaves, and layer 3 servers. I could create multiple pools. I can do some fancy things, but I won't. For the loopback addresses, I will. I will say my switch IP addresses for leaf and spine come from one pool, and my server IP addresses will be used from another pool. And you can see as you're going along, you can see what your progress is. You know, we can always go back to the build summary and see these progresses. The IP address links, these are the IP addresses that are placed on the interfaces. So again, for spine to leaf interfaces, I'll use the switch IP address pool. And for the servers, this is the IP addresses that are assigned, that are going from the leaf port to the server. So remember, we're going to do a layer 3 routing on the host, and we need to assign IP addresses for this purpose.
Let's see. Oh, we have a comment that David Barnum said, happy to see pooled resources in Apstra. Just pick the damn IPs for me. And then someone responded, you wouldn't prefer to record them in a spreadsheet. This is actually one of my shticks during this presentation. Yeah, the spreadsheet thing. That's like when you're designing a network and you're like, okay,
I'm going to sit down
you're
now.
sitting here, you're typing, right? And you're going to make loads of mistakes potentially, and it's time consuming, and it's, again, one of those things where you could spend hours doing it, you could be doing other things. You could be getting drunk. Which would be better than doing that, right? And we'll see later, actually, a cool feature where you know, it also generates the cabling, all the cabling specs, and you can download this information from this tool in spreadsheets. And there's a little icon that shows you that. And there's a whole bunch of things where you can click this icon. And I've like flipped out when I saw this because there's like, you know, everyone has something that's sort of been, it seems trivial to maybe other people, but it's been a bane of your existence because, you know, something bad keeps happening because of it. How many times I've made a spreadsheet, you know, okay, made mistakes because I cut and pasted and didn't replace the right things, but also how many times I created that information and went through that pain and put it on, you know, the L drive and told everyone that the spreadsheet is on the L drive. The L drive. I sent an email out. I sent it to everyone. L:/the stuff. And eventually, right, the facilities guy or someone, like one facilities guy, let's say, he downloads the spreadsheet and he puts it on the O drive. And then he tells everyone, well, now it's on the O drive because it's the facilities shared drive. And then I make changes to my spreadsheet, and that doesn't get propagated down to the O drive because those pixies and fairies don't exist. So mistakes get made, and it, you know, when I saw that icon, I just got a little emotional because now you can say, you know, if you're not going here, if I make changes, you know, go to the tool, download. There is no shared drive. There's the tool. If it ends up on the shared drive, then, I don't know, we get to chop you into pieces and spread your body parts all over Disneyland. Like something terrible, right? That's what you deserve if you do that. So, anyway, sorry. Awesome. Like, you don't have to make the spreadsheets. You don't have to deal with distributing them, right? You don't have to make the mistakes. It's magic.
All right, well, let me show you what he's talking about. So under system, where we had the topology, you also have links. And what this is the cabling map that Derick was referring to. So as we're making decisions and we're allocating pools, we can see exactly this cable map. Meaning, and here's the icon right here. Wait, I'll make it really big. So, you know, we can see it. There it is. That is the download icon. It will download a CSV file, and then, you know, all bets are off. But, you know, there is the icon that Derick really, really loves.
Yeah, it's nice.
Yeah, it is nice. But the information is here, which means, like, before you even deploy this pod into service, you could give this to the facilities people, or you could use this information to create cabling diagrams, or you could take snapshots of our cabling diagrams. I mean, but it's here. It's a source of truth, and it's a record of information that was automatically built, so you didn't have to do the sucky drudgery of that task. There's no more copying and pasting, making that mistake. So I'm gonna finish off the build here, I know that this pod is going to connect to a router, and I'm going to select that router that I defined in my resources. And maybe the router team told me what the IP address has to be, so I put that in there. And finally, since I said I'm going to be doing DHCP relay, I'm going to put in the IP address 192.168.59.254. So that's the IP address of my DHCP server. Now, another thing that we can do, and this is really, really cool, is as part of the layer 3 service routing to the host, we can control what prefixes this pod advertises or doesn't advertise. So we were working with a very large cloud SaaS provider, and they said, we're running containers, and some of our containers are private, meaning they're like, say, our back-end workloads. And we don't want those IP addresses ever leaving the pod. They should never, ever leave the pod. And they gave us a prefix or multiple prefixes, and that would go into the internal subnets. And then anything that they said is valid would go into the external prefixes. So we even give you, essentially what amounts to routing policy control capabilities when you use a design that warrants it. Okay, so as an implementation engineer, I know that this build is now ready. I know that I've given the system every piece of information that it needs. And as a result of that, I could look at, say, the configurations that would be built. And through AOS, you could download these, you could version control them. You don't have to, but you can, right? Again, the button, right? So the only thing I'm really left to do is to assign this blueprint to these devices and then apply it, which you kind of saw me do earlier with the device swap, but I'm going to do this for this blueprint. Now, I'm going to make a mistake on purpose so that you see this. So let's say that I wanted to go and deploy this blueprint, and I go to my build devices, and I want to assign spine 1. And I click the drop down, and there's nothing there, right? You're like, well, it's an inventory. I know it's plugged in. You know what's going on. It's because when a device first registers to AOS, unless you pre-configure it into AOS, it'll show up as quarantined because we like to put guardrails in the system. And what you as an operator would do is you would approve these devices so that AOS would know that it's okay. And you could even add location information here to help the person. You might say, well, this is in rack 7, rack unit 23. And the process for me to point and click through all that is kind of tragically annoying. So I'm going to, again, use Ansible to do this. I'm going to say make approved devices. I'm going to say Ansible playbook approved devices YAML. And what this is doing is it's loading a file, a JSON or a YAML file, and saying, I've got some serial numbers. I'll show you the file, actually. It's fairly trivial. This is basically just saying, here's some serial numbers, and here are their locations. There's not a lot of magic there. But as a result of running that playbook and using our API, it's approved these devices and assigned these locations. Why is that relevant? Well, when I go and I assign the devices, what I'm going to do here is I can see that I get the serial number, I get the host name, but in a default scenario, they're all cumulus, so that's not really helpful. But the location field helps me. So I know I want spine 1 to be my upper switch, and I know that I want my spine 2 to be the lower switch. And again, with the Celestica, right, I want that to be my upper switch. And again, as I'm doing these assignments, what we're going to see is AOS is now starting to gather information from these devices. Are your interfaces up? Are they connected to the right place? Is my external router up and ready to go? So what I'm going to do is I'll let this gather the information and say it is ready to go before I click deploy, because it really doesn't take that long. It's a fairly fast data point collection.
So this is this is something else that should be explicitly pointed out. You're actually deploying the network in a sort of very carefully staged way. With our universal ZTP server, when you put the device in and it boots up, the first thing that happens is we want to make sure that the right NOS is on that device, right? So, and that's happening in an automated way. So you're not making that mistake. Once that is done and we have our agent software on it and it's communicating back to the box and you've assigned it to a blueprint, before we deploy the routing config, we put LLDP on. And we do that to verify that the topology matches, the intended design. Then you deploy everything else on top of that. So it kind of goes in stages. And sort of, think about this. I've worked lots of places where, the standard was, because, again, the architect controlled everything down to the configs. You had generated configs. If you were doing implementation, already available to you. So you're just dumping whole configs onto devices. And what if something goes wrong? Well, now you have that whole plate of spaghetti to troubleshoot. Is it BGP? Is it LDP? All this stuff is configured now, so what is it that's going wrong? So another benefit of decoupling it is that you can now deploy the network in a safer, validated way in stages.